Hello and welcome to a CIEEM webinar on district level licensing for great crested newts, species distribution modelling. My name is Christy Hamilton and I am the Professional Development Coordinator here at CIEEM, and I will be shortly handing over to Dr. Ben Payne from Natural England, who will be presenting this webinar. Before I do so, and while we are waiting for everyone to join us, I'm just going to mention some upcoming CIEEM events that you might be interested in. So we have our autumn conference coming up, which is on planning for success, maximising biodiversity through planning and strategic land use management. This will be taking place on the 19th and 20th of November in Llandudno, and there are still spaces available if you would like to book. And you can do this via the training and events area on our website. We also have some upcoming training on developing skills in ecological impact assessment. And again, these, along with other training courses, can be booked through our website. Finally, we have some upcoming webinars. So we have one on amphibian entrapment in drains, a new approach to mitigation, which will be taking place on the 7th of November. And we also have further webinars on district level licensing for great crested newts. And we've got one on habitat delivery for the Natural England led scheme on Tuesday, the 5th of November, and one on how to apply, which is on Tuesday, the 26th of November. And again, these can all be booked via the training and events area on our website. Before I hand over to Ben, I'm just going to show you how to ask a question. So we will be doing a Q&A session at the end of the webinar, but just to show you, there should be a Q&A button at the top of your screen. If you click on this and type in your question and press send, they will then be answered at the end. Okay, without further ado, I will now hand over to Ben. Thank you, Ben.
Thank you. How's that? Can you see that?
Yes, that's great.
Thanks. Okay, well, it's great to have the opportunity to talk about the species distribution modelling that is an integral part of district level licensing. Today is really, if my screen will change. This was working 2 minutes ago. Try that again. Technical difficulties. Hang on a second. Okay. For some reason, whenever I try and click any button, it's not working. So I'm not quite sure why this has suddenly started happening.
I'm not quite sure what to suggest, Ben.
Working as when I'm on it, but
Ben, you could try sending it to me, and I could try and share my screen, and you could tell me when to flick the slides.
Yeah. Okay, I might have to do that. Apologies, everyone. I have no idea why it suddenly stopped working.
I wish I had some holding music, but I don't, I'm afraid.
Okay, Gregor is in its way. Very Strange that suddenly stopped working. Well, I'll begin talking. The main aim of today was just to talk about the species distribution modeling and how it is an integral part of the Great Crested Newt district level licensing project. And we're going to look at how we build, well, we'll look at what a species distribution model is, how we build those models, and how we then use them. So we use them in terms of analysis of the connectivity. We look at risk zone mapping, so we'll look at how it develops the risk zone mapping, and how they go to contribute into the strategic opportunity areas for conservation as well. I don't want to get too far ahead because I don't want to lose the slides, but the important thing to remember about the SDMs, the species distribution models, is that they really are quite integral to the entire district level licensing project. They really do feed through all of our modeling and all of our ability to map risk zones and these strategic opportunity areas that will then help us deliver the ponds and the conservation into the correct areas where we hope we'll do the best and have the best benefits for newts and help increase both population and distribution of newts across a landscape scale environment. How are we doing, Gregor? Any sign?
No sign yet. No, this is technical gremlins. I imagine it's quite a big file, so it's somewhere in the ether.
Yeah.
Could you put it onto OneDrive or something like that and send the link? So, try it that way.
Oh. Let's just check it's gone. It's definitely sent.
Ah, yes, it's coming in. It's only 18.2 megabytes. Thanks, thanks, Ben. It is taking quite a long time to come through. I can see that already. It's there's a long loading bar.
It's good to use up your mailbox anyway, Gregor.
Yes.
So again, apologies for this. It's one of these things. We did test this about 25 minutes ago and it was working fine.
Aha. Here it is. Okay, let me just try this. Okay, can we see that?
I can see it, so hopefully everybody else
Good.
can.
Yes, I can see
and the slides work. All right, Ben, shout at me to change the slides.
Click about 5 times. So, and once more. There we go. So this is what I'm going to be sort of discussing today. So we've got these evidence and predictive layers that go into the species distribution model, so we can predict where suitable habitat is. We can look at connectivity, risk zone mapping, and strategic opportunity areas. So if we pass on to the next one. Yep. And so species distribution models also have other names: habitat suitability models, environmental niche models, but you'll see other names in the literature as well. Click on a couple of times, Gregor. And when we create a species distribution model, we can incorporate all sorts of different information. So we can include the species distribution, its presence, absence. You can do abundance modeling as well, but not for this project. We're using presence, absence. You can include climatic needs of a species. So for example, the wettest 3 months are quite important for newts, but actually we're not using climate in this project because we're modeling at quite a small scale, and therefore the climatic change around the areas tends to be quite small. We can include ecological niche requirements, so the habitat preferences of a newt. So the woodland, grassland is quite important for newts, but it could be all sorts of various different habitat preference and ecological niche requirements. We can include abiotic and biotic features, so we can include soil types, quite important in some areas. It might be pH levels of the soil, which helps us understand maybe the pH of in the ponds. We can look at trophic relationships in species distribution models. We're not doing currently for GCN, but you can start to include the presence of predators and that sort of thing. One last one, where I go. And basically, we can plug in whatever we know about the species that we're trying to model. So for this project, we're looking at dispersal characteristics as well, to look at how they may disperse across the landscape. And one more, Gregor, I think. And the important thing here is that we can predict for the present, which is currently what we're doing, but we can also predict into the future based on climatic, maybe the climate change or potential changes in land use in the future, but we can also go back in time as well. And you can go spatially as well. You can predict into the different spatial areas, although that becomes a bit more tricky. Thanks, Gregor. When species distribution models were first envisaged in the statistical and research world, they typically used one type of statistical modeling, so maybe GLM, which is generalized linear models, and then they predicted where the species would have suitable habitat or would be based on that one model. What we're using is actually ensemble models, and ensemble models actually incorporate a number of different statistical modeling techniques. So we're actually using all of these statistical modeling techniques. We create a species distribution model using each one of those, and then compile them into this ensemble model, which gives us a better confidence around the predictions that we're creating. Thanks, Gregor. Now, anybody who's on Catherine Burgess's webinar will recognize some of these figures. So I just wanted to explain again where we're getting our data from in terms of GCN observations. We're using internal data, our class license returns, our evidence programs. We can use external data where we can access that. And of course, we've been doing the random stratified surveys over the last 3 years, and you can see how extensive they've been over on the right-hand side there. Let's go. So when we create our species distribution models, the first thing I want to express is the fact that these are ecologically driven models. So we are putting in information that we know is ecologically important, or we believe is ecologically important to great crested newts. So we start by saying, right, where do we know newts are and aren't? So that's the points we've got there. Click on one, Gregor. And then we start to build up different layers to try and understand why those newts are there or aren't there. So we might use, this is the land cover map. So we might use this and say, is it something to do with the specific land cover, or is it to do with the density or the distance to different parts of habitat? And again, Gregor. We can then add another layer, so we can say, okay, is it to do with elevation? So over on the east there, you can see higher elevation than on the west, but that may also be linked to the habitat itself. So it may be to do with grassland at low levels or whatever it might be. So they interact as well. So it's an additive and interactive model. And if we click on one more, we'll start to see the pond density as well. So this is the number of ponds within a 250 meter radius of any single point. So we can start to say, okay, are ponds at high elevation important, or are they less important than the low level ones? And that sort of thing. That's how we start to build these models. And you can see down the right hand side there the different sort of habitat and variables that we can plug in to these models. That's good. And once we've built our model, it creates a prediction of presence or suitable habitat. And what we see here is the prediction between 1 and 0, or actually I actually convert it to 1 and 1, 0 and 1000, because it just makes easier sense to me. And what we see here is that the hotter colors, the reds, that's where suitable habitat is really predicted to be present, and then the darker greens where it's more likely to be unsuitable. But actually what we want is just to say what we believe is suitable and what we believe is unsuitable habitat. So if you click on Greg, we do that by using a threshold value or a cutoff value. So a number between 0 and 1000 will be set as the threshold, and any value above that threshold will be set as suitable habitat, and below it is unsuitable habitat. And you can see for Cheshire here that there's an awful lot of suitable habitat, but Cheshire is GCN central, as some people will say. So, you know, we'd expect to see an awful lot of suitable habitat. There's an awful lot of ponds as well in Cheshire, which is another reason. We set the threshold by balancing the ability of the model to predict presence and absence correctly. So where you find that the prediction of presence and absence are both very high and very close together, that will typically be the threshold value that we will set. And that's how we create these suitable habitat maps. That's great. When we're talking about the model performance and how we can evaluate the model, we can look at sensitivity and specificity, so the ability for the model to correctly predict presence and absence. And we can use those sensitivity and specificity values to create the model scores as well, which are the true skill statistics, the TSS, and the area under the receiver operating characteristic curve, which is a bit of a long-winded way of saying AUC or ROC, depending on which one you want to use. But they allow us to broadly rank the models that we are producing, and we are typically aiming for good, and of course we're actually aiming for excellent models wherever we can based on these scores. Thanks, Gregor. When we're building the models, and when we've built the model as well, it's good to be able to understand, because I was saying that they're ecologically driven models, it's good to be able to look at what's going on in the model and say, right, is this what we would expect for Newts? We do this using the model response curves. So each model produces these model response curves. On the y-axis, you can see the contribution to likelihood of suitable habitat. So the higher it is, up towards 1 there, the more likely suitable habitat will be. And then on the x-axis, you've just got the value of the variable. So the number of ponds within 250 meters, that's pond density, and that's this one here. But it might be distance to woodland or density of woodland within 250 meters, whatever it might be. And you can see from this plot that pond density over 3 is a pretty good indicator that it's going to be contributing to the suitable habitat of great crested newts. That's great. I just wanted to show you a couple more of these as well. These are the common predictors that are in all models, really, but they are then supplemented as well with other variables, which we'll come on to. So density of arable, they don't like an awful lot of arable, so that's on the right-hand side of the top left. They much prefer there to be less arable than lots of arable, and that goes along with what we understand, but they can handle a bit of arable. And that's good because if you look at a map of England at the moment, there's quite a lot of arable in it. Density of grassland, they like there to be some grassland, and that makes sense because it typically can be used for feeding those grassland areas. But again, they don't like lots and lots of grassland. They don't like it to be dominated as sort of a monoculture of grassland. Distance from woodland, they like to be close to woodland, which is, again, understandable, hibernation or refuge from heat during the summer. And density of woodland, they like there to be sort of good level of woodland around, but again, not so much if it's dominating the environment, because they need a bit of grassland in there as well, or whatever it might be. And then at the bottom left, you've got a different type of pond density plot. So all the others have been nice smooth curves, and that's because they've been created from one of the different modeling types. It's whether it's generalized linear model or generalized additive model. These models produce nice smooth curves, but random forest modeling, different statistical modeling technique, uses you start to get these stepped plots coming out. Now, if you're wondering about the different colors on these plots, the different colors are just different runs of the model. So when I'm creating a model, I'll run it many times. So I've run it 10 times here, and when I run it 10 times, it takes 75% of the data, the presence and absence data, randomized 75%, creates the model based on that, and then tests the model against the other 25%. And that's what you're seeing, the different colors here and the different responses. So typically you'll see the same response, so the same curve, but in your distance to woodland curves here, you're seeing a bit of variation. So that might suggest that actually distance from woodland may not be that important in that area. But this is the sort of process that we go through. Thanks, Gregor. Other relationships that we might see, and these do vary from area to area as they become more important or less important in different areas. Soil pH, so there's a preference for neutral soil typically, and that makes sense because they tend to prefer neutral sort of water pH. Flood zones or distance from river, that's quite important in some places, not so much in others it tends to be, but that's to do with predation risk. Soil drainage, to do with pond permanence. Next nearest pond, where you've got a pondscape which has got sort of great distances between individual ponds, next nearest pond can be quite important because newts tend to like pond clusters. And in some areas, heather might be more important kind of for urban, whatever it might be. And as I said, climate tends not to vary so much over the model area. Thanks, Gregor. Something else that we do with, in conjunction with the species distribution modeling, is look at the fragmentation of, or the potential fragmentation of great crested newts across a landscape. So that's our connectivity and metapopulation analysis. And what we do here is we link all ponds, which are 1 kilometre apart. So in Cheshire, there's 20,000 ponds and lots of them are all linked. And we say, right, let's create a least cost path between those ponds. So least cost path is just the path of least resistance between ponds, and see if a newt might be able to get from one pond to another pond 1 kilometre apart. That's kind of the maximum dispersal distance for newts. To do that, we say, right, suitable habitat. If it's suitable habitat, a newt can disperse and traverse the area quite simply. If it's unsuitable, then it's got a greater resistance to travelling and it may not get there. But we also include barriers, which are shown on the left-hand side there: motorways, rivers, urban areas, A roads. And then we add in areas of higher resistance, so B roads, suburban areas, unsuitable habitat. So they can get across those, but there's a greater cost and they may not eventually get to the far side. And what you can see on this plot is the hotter colours, the yellows and reds. That's where there's lots of least cost paths overlapping, which may suggest that they're really important for dispersal over time. Let's go on. And then we also have a look at what we believe might be metapopulations or might be classed as populations And what we do is we say, okay, let's link all of the ponds which are within a fragment, and we give each one a different colour. And that's what you can see here. So lots of different metapopulations across Cheshire. Let's go. And this plot here is just to highlight how that works. So you can see the main A roads are acting as barriers, and the rivers are acting as barriers as well. That's great. So I know this has been discussed in the past, but I just wanted to recap on what the risk zones are. You can go down to the bottom there to the green zones, Gregor, thanks. So we've got 3 risk zones. We've got the red, amber, and green. Red tend to be triple SIs or other protected areas with GCN as a feature with 500-metre buffer around those. We've also got stakeholder-defined red zones as well, which are based on a set of criteria which highlights the key local populations. And in red zones, we use the existing licensing measures. Amber zones are where we predict suitable habitat to be, and where they then aggregate it. I'll explain that in a second. We have also where we've got great crested newt observations, but they're not predicted in the model. Then we can put those in as well, and we put a 250-metre buffer around those. And there's an increased compensation for ponds in the amber zones. And then the green zones are the remaining area where we don't predict suitable habitat. So the aggregation process I mentioned briefly for amber zones. So in the hatched areas on this plot, that's where we predict suitable habitat to be for great crested newts. And then if there are 2 areas of suitable habitat which are less than 250 metres apart, we then combine those. So we will link those together. And that's to suggest that maybe they are important routes for dispersal over time. And that's the aggregation process. Thanks, Greg. And we end up with a rather beautiful green, amber, and red map for Cheshire. The red zones actually in Cheshire were stakeholder defined, but of course, as I've been saying, that there's an awful lot of GCN in Cheshire, so we've seen an awful lot of amber zone across the landscape. Let's go. So that's the risk zones, a key part of how district level licensing functions is using the risk zones. And then the next stage is to look at the strategic opportunity areas as well. So strategic opportunity areas are allow us to highlight for the habitat delivery bodies the most important areas we believe for great crested newts in terms of creating or new distribution areas or improving the population levels. So they really are about us highlighting the best areas for newt conservation over time. This is where we put the new ponds, or we restore ponds. And there are 2 types of strategic opportunity areas. They are core. Now the core strategic opportunity areas are where we understand that there is suitable habitat for newts already, and therefore what we're doing by putting new ponds in there is increasing the population. And then we have the fringe strategic opportunity areas, which is a kind of a 250-metre buffer around the core areas where there's typically quite low pond density, but there may be suitable habitat. And therefore by putting ponds into those fringe areas, we're hoping that we will increase the distribution over time. One more click, Gregor, there, I think. And the point of the strategic opportunity areas and the whole project really is to put money into this land management at a landscape scale. So we're not looking, we could be looking across a number of LPAs if we have that sort of agreement with them, and we could be putting the ponds into the best places across wide scale areas. Sounds good. There's going to be some clicking happening here, Gregor, one at a time though. Okay, so what we've got here is how we build up the strategic opportunity areas. We do it using what's called a weighted sum mechanism. And what we're trying to do here is understand how many suitable habitat features are in different areas across a landscape. What I'm going to show you here is a very simple example. They get more complicated than this. And here I'm actually showing you how we create the core strategic opportunity areas. So the first thing we do is we look at pond density. Pond density, very important for newts. What we say is, okay, where there's a pond density, so number of ponds within 250 meters is greater than 2. So if you remember back, we were looking at sort of 3 ponds, pond density of 3 and above being great for newts. Let's identify all the areas where there's a pond density of greater than 2, and we'll put a 50 meter buffer around that. Next, we want to say, right, where is the model already predicting suitable habitat? So we add that in as well. And you can see on this slide, they overlap quite a lot, pond density with the model prediction. That's not the case everywhere, but it is in this example. The next thing we do is we say, right, where are the suitable, where are the habitat features that are beneficial for great crested newts? And let's score those. So in this very simple example, we're saying if there's grassland within 250 meters, give it a score of 1. If there's woodland within 250 meters, or if the rivers are between 100 and 1,000 meters away, we don't want to be too close to the rivers because of the flood risk. So score each of those 1. So you've got a maximum score of 3. But we then have negative scores, and we can also exclude areas as well. So one more click, Gregor. So we've got arable areas. So what we're saying in this model is we don't want to place a pond potentially in an arable zone. Okay, that's not always the case. Maybe they are great areas to place ponds, but this is a very simplistic example. So we say arable gets a negative score. Let's not place them in arable where possible. And what we've done here is we've said, right, let's exclude all urban areas with a 400 meter buffer around them. We don't want to be building or digging ponds or restoring ponds quite close to urban areas because there's a potential of development over time near those areas. So that's how we can score it. So you've got a maximum score of 3, a minimum score of -1, and you can exclude areas as well. One more click, Gregor. We can also do other exclusions as well, and we typically do. So we can exclude protected areas. We exclude flood zones. We can exclude aerodrome safeguarding areas. But we can also exclude very low pond densities. So we've excluded anywhere below 3 ponds on this example, because they will then be used in the fringe zones anyway. Or we can exclude very high pond densities as well. So if we've got areas which have got incredibly high numbers of ponds, we may want to actually exclude those, because adding an extra pond in those areas won't really benefit that sort of area anyway. One more click, Gregor. So if we add all of these up, we get this weighted sum value between -1 and 3. And what we're saying to the habitat delivery bodies is, let's focus on these dark purple areas. These purple areas, dark purple areas, are where we've got all the habitat features, and we've got prediction of suitable habitat anyway. So let's get some more ponds into those areas. Thanks, Gregor. We then extrapolate that out to an entire county, or whatever the area is we're working in. And here you can see we've got core weighted some values. So that's the core strategic opportunity areas. And then around those, we do exactly the same scoring, but with the fringe areas, the 250 meter areas. And what we can do there is we can say, okay, let's do the fringe, and we can put ponds in there, and we'll be increasing pond density, and that'll be fantastic for newts over time. Thanks, Gregor. Something else we do with strategic opportunity areas as well now is that we can say, right, let's add in all the areas where we know great crested newts to be. If we know great crested newts are there, then people, the habitat delivery bodies can actually focus on those areas and say, these are the areas where we almost guaranteed to get colonisation over time, because then we know that the newts are actually there. It's not so important in places like Cheshire, because if you speak to Cheshire ecologists, most of them will go there everywhere. But in some other areas, these might become more important in terms of focusing and targeting delivery. That's Gregor. That's really where my involvement ends. The next stage, which has already been discussed by Catherine a couple of weeks ago, is actually the monitoring of the new ponds that go into place. And this is just a recap. You know, we are monitoring over 25 years. We are doing management visits, and we are contributing to the national monitoring program as well. But the important thing is that by monitoring, we can understand colonisation rates. And if we can understand colonisation rates, if we see that in certain areas, ponds are being colonised really quickly or not being colonised so quickly, we can adjust the strategic opportunity areas. We can adjust how far away the fringe areas are or the core areas are from existing habitat. And we can hopefully over time understand a bit more about colonisation of ponds. Yeah, so just a quick summary. This is moving from site-based mitigation to a landscape scale conservation, but it's based upon this strong evidence base and this ensemble modelling, including lots of different statistical modelling techniques, and we also use geographic modelling as well as part of this with the weighted sum. It's better for newts, more conservation funds, targeting areas we hope will benefit them in terms of distribution and population. And we can start to look at how we can benefit them in terms of connecting meta-populations together. And then it's better for developers as well, we hope, in terms of understanding upfront costs and reducing development delays. And that is that. Thank you very much.
Thank you very much, Ben. Before we've had a few questions come in. Before we move to the Q&A, I will just show you how to record this webinar. So you can record this webinar as structured CPD, and it relates to the following competencies. So environmental management, policy, legislation and standards, and scientific method. Okay, so we've got a couple of questions already. So Pip asks, which SDM software are you using to run these models, and will ecological consultants be expected to use similar modelling in future?
It's a good question. So the easy answer to that is that we should be doing, we will be updating the species distribution models every 5 years, and as we get more information about newts and their locations, and also we'll have different habitat layers over the time as well. So we'll be doing all of that. If anybody wants to get involved with species distribution modelling, it's all open source software. We use Biomod 2. It's an R package. I'm happy to discuss that with you, Pip, if you want to. I'm very happy to be involved with that.
Fab, thank you. Another question from Helen. Given 2 of the 3 years of baseline eDNA field surveys have been drought years, presumably it's likely that existing populations and distributions have been under-recorded. What are the potential consequences for this, for the modelling and interpretation of future monitoring results?
Another good question. So yes, we do understand that it may be drought affected, but actually we've seen higher than expected presence data coming through. And the important thing to realise is that we don't always just use presence and absence data when we're modelling. We can use presence and pseudo-absence data as well. Pseudo-absence data is randomised absence data, which helps the models sometimes train themselves in terms of where we're not sure whether absence is true absence or not. So that's another method we can actually use. Whether we're under predicting or over predicting, what we also do in the risk zones is if the model has quite a low sensitivity, so its ability to predict great crested newts presence is quite low, we can actually bump that up. We can force the sensitivity to go higher, which reduces the specificity, so its ability to predict absence that goes down. But what that tends to do is it tends to start to over predict where newts are, and we can use that in the risk zones to protect a greater area where we believe great crested newts will actually be. But we do a different thing with the strategic opportunity areas to ensure that we're not doing over prediction in that, because that would then potentially start us putting ponds not near great crested newts. So that's how we sort of try and balance that.
Great, thank you, Ben. Another question, district level licensing only appears to apply where a GCN pond is to be destroyed to make way for a development. What approach do we take when the only ponds with GCN are on adjacent land, but the development will result in the loss of immediate terrestrial habitat and site clearance work could kill or injure GCN? Is the developer required to undertake any mitigation? If so, what?
Gregor, do you want to answer that one, or do you want me to?
Yes. Yeah. Can you hear me, Ben? Hopefully everyone else can. Yeah, great. Yes, we do consider impacts on ponds, both on site but on off-site as well, within 250 metres. So we've gone through how we consider impacts in some detail in the first webinar, which is recorded on YouTube. Perhaps, Christy, you could share the links to those recordings at the end of this. But when we're considering impacts for district licensing, we look at ponds on site and off site within 250 metres, and then we consider the impacts to terrestrial habitat of those ponds off site within a 250 metre radius around those ponds. So it's quite difficult to explain without some without pretty pictures. If you've got any if the webinar that's been recorded doesn't answer your questions, then please let us know. But hopefully, if you can be directed to that, then that should answer in a bit better than I can here.
Fab, thank you, Gregor. Anna asked, how regularly are you anticipating to update the risk zone map based on new data, e.g. licence returns?
Risk zones should be updated every 2 years, we believe, in accordance with the length of the licence.
Okay, thank you. Diane asks, if abundance of GCN wasn't used in the SDM, how can the long-term population status be monitored?
Yeah, so we can't use abundance in the SDM because when we go out and survey, we've been using eDNA surveys, so that actually only picks up presence and absence. So that's the issue there. But when we're doing, we also have all the information coming in from our class licenses and that sort of information, and we'll have other surveys coming in as well. We're also going out to survey some of the populations in the new ponds that we're creating as well. So hopefully over time we should build up that sort of that data set to understand what's happening across the landscape scale. We're also contributing into the national surveying schemes as well, so we're getting information from those as well. So hopefully we'll get this far wider picture over time.
Great, thank you. Another question, it was suggested in the previous webinar that once a developer has paid the necessary fee and Natural England has given the go-ahead to destroy a GCN pond, ecologists can undertake an amphibian rescue in order to minimise the number of amphibians being killed. In such circumstances, would the capture, transportation and release of GCN require an EPS license?
Yeah, that's a good question. The license that's issued to that developer will allow that as part of the license. So I think the answer is yes. You will need a license, but that's provided as part of the district license that's supplied to that developer. And they'll be able to use authorised people under that license and accredited agents and that sort of thing.
Great, thank you. Holly asks, what is the upper limit for pond density in the core areas?
It depends on the area that we're modelling at the time. So typically we haven't really put on an upper limit, but we can if stakeholders raise queries about that sort of thing. So, you know, in Cheshire and in Kent, we've had upper limits of sort of 20 pond densities of 20 within 250 metres. So we can look to limit the core areas if we are required to, and that comes a lot from the stakeholder input and getting their understanding of the area as well. So really, it's based on stakeholder input.
That's great, thank you, Ben. So it looks like we have one last question from Lynn. I believe Natural England is starting to look at this approach for bat licensing. How would you envisage modelling of this kind to work, given that most EPS licence applications are for species commonly occurring across the country, including suburban areas?
Hi, Lynn. Ben, you might have something to add to it, but you said that this approach is probably an approach, a different approach to bats we're looking at the moment, but certainly not this approach, and we wouldn't expect to be able to copy and paste this across to bats or any other species. So we've been, as an example of some of the work we've been trialling to date, we've been working with Stuart Newson from British Trust for Ornithology up in Norfolk, and he's done some modelling work, which is all available and published some papers on the back of it, off the back of the Norfolk Bat Survey. So you can go there and have a look at some of the work he's done. And we're trying to work with Stuart and also test some ideas with our bat expert panel to see how we might use models, or if they're appropriate at all, to improve the way we do things for bats.
Yeah, and I'll just add briefly on that one. With bats, where I've been involved, it's an addition and an important part of it is looking at dispersal routes and what areas they use and different routes that they take at different times and that sort of thing. So it's about adding extra layers into potentially species distribution models or whatever modeling techniques that we actually find to work best for bats. But that's just a case of working with the bat experts and understanding the ecology. And as I said throughout this one, it's all about the ecology of the species, and that's what helps drive these models over the long term.
Great, thank you both. We've had a couple more questions come in. The government has spent millions on Brexit planning. What preparation has Natural England made for changes to EPS licensing once we leave the EU? Have the GCN mitigation guidelines been amended?
Yeah, thanks. I was going to say the name, but as an anonymous attendee, thank you. There's a hell of a lot of planning that's gone on, and so it's worth saying that there won't be any changes. Essentially, there'll be changes to the wording, but there won't be changes to the protection afforded to EPS species at the moment. And as for the mitigation guidelines and their updating, we've got a large team who are working to update all our forms and things ready for Brexit. That's one of the ones. I'm not sure whether we have updated it yet. If it needs updating, then it will be.
Great, thank you. One last question. How far off do you feel Natural England are from offering district level licensing as an option throughout all counties?
So again, I'll refer you to our first webinar, and we put a table out with our setting out our timetable for rollout. So we're still aiming for 150 local authorities, but as some of you will be almost certainly aware, time has slipped. So we're hoping by September next year, September 2020, that we can have district licensing options available in approximately 150 local authorities.
Great, thank you both. I think that's it for the Q&A. So we've got no more questions. So yeah, just say a big thank you to Ben and Gregor for the presentation and being part of the Q&A. And thank you all for joining us. We will be sending out a feedback form this afternoon, so please do fill that in, and I'll also include the links to the previous webinars as well. So yes, thank you all very much, and we hope that you join us at the next CIEEM webinar.
Thanks very much.
Thanks, everyone.
Thank you, bye-bye.